All right, let's take a look at number 4. Use the graph of the density of aluminum provided below to determine the approximate mass of aluminum samples with the following volumes. And so here what we're doing is we're using the density equation essentially. Remember, density equals mass divided by volume. And so when we have mass compared to volume, we have a line that represents density. Now this is most definitely a straight line because both the x and the y axes are increasing by typical arithmetic means, nothing exponential, just going up by 1, going up by 5s. And because this is always aluminum, the density of aluminum will remain constant at constant temperature and pressure. It should be a straight line. And so what we're doing is we're going to be given a series of volumes, right? Volumes here on the x-axis. And what we're going to end up doing is we're going to find that location, whatever location we're asked for, on the x-axis. And once we're there, we will simply trace up to wherever the density line meets that x-axis, and then we will trace over to the y-axis, and that will be our mass reading. So it's actually kind of simple the way we do this. Just understanding that x-axis measures volume, the y-axis is measuring mass. So let's start with A, 8 milliliters. So let's find 8 right here. We're going to track this all the way up. Right there. We'll track this all the way to the y-axis. And so what I see here, it's not quite halfway between 20 and 25. It's not super close to the 20, so I'll just estimate that it is 22 grams. Okay, 22 grams. Now, estimating here is fine. If you write 21, if you write 23, it's not the end of the world. Okay, you're obviously doing the thing that you're supposed to be able to do to solve this problem, which is utilize the information in the graph, not getting super cranky if you can't trace that line perfectly straight. B, 1.5 milliliters, so that's going to be right in between 1 and 2. Trace that up. Boop. Now over. Yeah, I'm going to go ahead and estimate that is 4. And again, the y-axis is measuring grams. So C, 7.25 milliliters. Okay, so not halfway, but about a quarter of the way. Come on, steady hands. Alright, so that's pretty much right on 20. So I'll just go ahead and estimate that is 20 grams. Last one is 3.5 milliliters. 3.5, halfway between 3 and 4. Up to the line. Alright, so that ends up being a little bit below the 10.0 mark, so I'll go ahead and estimate that is 9 grams. So what we've done here is simply taking an x value, okay, a value for the x-axis, and tracing it up to the density line, and from the density line moving over to the y-axis, we've been able to identify a mass associated with a certain volume of aluminum, because for whatever volume we are given, there has to be a consistent relationship to mass, because density is consistent, okay, it's constant. And so in order for this value for density to stay the same, because it's still aluminum, right? It's always aluminum. It's not like the density is going to change. If volume changes as we go up and down this x-axis, so does mass. And there's always going to be a very specific mass of mass of aluminum associated with a particular volume of aluminum.